In this tutorial, I will show you how to work with various tools attached to the end effector of the industrial robot. As you can see, I will use a pen as the tool instead of vacuum gripper. So, when I have changed the tool, I have also changed coordinate system of that tool. Firstly, we have to measure tool centered point of new tool. On the screen of the Teach pendant, go to Setup, Measure, Tool, and use the first method. Now you have to choose one of 16 memories for the tool coordinates. I have chosen number 11. As you could read on the screen, now you have to line up the tool centered point of the pen on auxiliary apex from the first direction. In the case this task is done, press the Measure button on the bottom of the screen and then press the Continue button. You can read that you have to line up the tool on the apex again, but with another direction. In summary, you will do it 4 times until the drive system of industrial robot will calculate the distance of tool centered point from end effector in all 3 axes. After this procedure, you can see the distances of the tool centered point from end effector of the robot and also inaccuracy that takes almost 0.6 of millimeter. After that, press Save button. Now it's good to check the procedure. To check it, you have to unset F coordinate system and set the coordinate system of actually tool. By moving the robot in Z-axis, the robot have to move in axis of the pen. By moving in Y and X axis, the robot have to move in perpendicular directions. Now it is important to continue with measuring. I will measure the base systems of two different workspaces, as you could see on each desk. How to do it? On the screen, go to Setup, Measure, Base, and use the first method. You have to choose one of many memories for the base coordinates. I have chosen number 18. Now choose the measured tool that the measuring of the first base system will perform due to. Firstly, line up the tool centered point into origin of first base system. Click on Measure key and then Continue key. Secondly, line up the tool centered point to a point on the x-axis with minimum distance 50 mm from origin of base. Click on Measure key and then Continue key. Thirdly, line up the tool centered point to a point on the XY plane with positive Y volume. Click on Measure key and then Continue key. Now you can see coordinates of new base system. Now try the same procedure for the second base. Number of second base will be 19. Now I will work without any command, but I use the same procedure. To check the correct measuring of these tool-based systems, I will make a new program. Now I'm going to select the program. In the program, I will set 3 positions of the first base system and linear motions between them, so the robot will draw the triangle. It's important to set correct number of the base, it means 18 for the first base, and the correct number of the tool, it means 11, before touching up the positions. Note that the first position, first instruction is PTP instruction due to traveling from home position of the robot to first position onto the triangle. Following instructions are made by linear motion. Don't forget to check the tool and the base number. Set position of the second point. And the third point. After 3 points, we will close the triangle by linear motion, but into P1 position. Don't touch up now, just press CMD OK and confirm No. Now I will test the program. Slowly motion into home position. As you can see, the program is correct. After testing motion of the robot within the first triangle, I will change the number of bays from 18 to 19. No more change. If the robot will draw the second triangle, measuring of the method was right.